is probes. What is called a probes? Probe, you are all familiar with electronics laboratory. Suppose you are having oscilloscope. Here you have to input to be measured is here. You have to connect a probe. This is called a probe. There are different type of probes. One is a active probe. Another one is passive probe. Passive probes. Some examples for active components are diode, transistors, SCRs, integrated circuits, MOSFET and so on. Passive component examples are inductors, capacitors, resistors. The component, we can see the first one, what is called the active probe. The probe which uses transistors are called active probes. Similarly, the probes which uses the resistors, capacitors and inductors are called passive probes. First we can see active probe. The schematic diagram of the active probe is shown in diagram, which uses the FET amplifier. This is your active probe. This one uses a FET as a amplifier. The voltage gain of the FET follower is unity. Unity means 1. Unity is 1, that its input impedance is high. What is the advantages of unity input is very high means the let us take this one is a oscilloscope. This one is a point to be measured. Here you are having a probe. If it is input impedance is very high means that it allows the entire input to the oscilloscope. Okay. That is the advantage of the high input impedance. Okay, the maximum transfer of input to the next level. That is the advantages of high input impedance. To eliminate the capacitance of interconnecting cable, the FET must be mounted directly with the voltage probe. Here, this is your FET. This is your input stage of the probe. To eliminate the capacitance of the interconnecting cable and a FET, that it has to be directly connected. Okay, then FET voltage follower is not directly connected to the oscilloscope. Instead of FET follower is connected to oscilloscope through a coaxial cable which is terminated with a characteristic impedance. Okay, here this is your output stage of the active probe. Here, instead of connecting simply through a coaxial cable, it must be terminated with characteristics impedance, that is Z0. Usually you may study the characteristics impedance in transmission line and waveguides. Usually suppose you are having a transmission line, this is your input stage, this is your output. Usually it will be terminated by characteristics impedance Z0 and then load. What is the advantage which is terminated by characteristics impedance means the maximum input is transferred to the output. If it is not terminated by characteristics impedance, some input that it get reflected back to the input side. So the frequency roll off or frequency will get affected. Therefore, simply connecting FET to oscilloscope through a coaxial cable. The coaxial cable is terminated with a characteristics impedance to provide a maximum transfer of input to the oscilloscope. That's why it is terminated by the characteristics impedance Z0. Thus the high frequency roll off of the frequency because of the capacity of the cable is avoided. That is avoids the capacity effect and then maximum transfer of the input to the oscilloscope. What are all the disadvantages of the active probe? There is no signal attenuation between the FET amplifier and probe. Here there is no any attenuator is provided. There is no signal attenuation will be provided, directly connected. Okay, this is one of the disadvantage. And the range of the signal handled by the FET probe is limited. The range of the frequency which is handled by this probe is limited for a few voltage or few volts. By adding an external attenuator, we can extend up to some level. Okay, then FET probe can be used for handling a larger dynamic range. Once we added a external attenuator, then the FET can be used for handling large dynamic range. Okay, that's all about active probes.